Again, I'd like to welcome everyone to today's TechNet Webcast, Introduction to SQL Server 2005 Analysis Services. It's my pleasure to introduce today's presenter. We have John Weston. John is a technology presenter for the Microsoft Corporation. And without any further delay, I'll turn the session over to John.
Thanks, Tracy. Appreciate it so much. Well, good afternoon or good morning or good evening, depends upon if you're watching this on a tape delayed. Welcome, and hopefully we'll have a good discussion this afternoon talking about SQL Server and Analysis Server with the new version SQL 2005. My name is John Weston. My email address is john.weston@microsoft.com. Again, that's just put a period between my first and last name at microsoft.com. I also have a blog that I do. You can go out to my blogs at blogs.technet.com/jweston. And I'll post both of those up here in the question and answer period here in just a few minutes. If you have questions, you can go ahead and put them out there for me, and I'll take a look at them towards the end of the presentation. I'm part of the Microsoft Across America team, and we go around to different parts of the country doing live in-person events about technologies that IT professionals are interested in. We also do webcasts like this. We do local user groups and are in a town near you. So if you're interested in finding out more information about our team, we have a team website, and it's called technetevents.com. And so you can go up to that website, see what we're talking about, what our current topics are, and when we're going to be in a town near you, or see some of the webcasts that we do just like this one. So again, welcome. Let's dive straight into SQL Server and see what we're going to be covering today with SQL Server Analysis Services. We'll begin with a discussion of some of the new features in SQL Server 2005, including Analysis Services. We'll take a look at where Analysis Services fits into the SQL Server Business Intelligence spectrum. One of the most important concepts we'll cover throughout the session today is Unified Dimensional Model, or UDM. UDM is new in SQL Server 2005 and provides a number of benefits over traditional OLAP cubes, and we'll see shortly. We'll also use Analysis Servers to define and deploy a cube, discuss multilingual metabases, and talk about key performance indicators. By the end of the session, you have a good idea of what SQL Server 2005 Analysis Services is, what it can do for your organization, and how to start using it to provide relevant information for making business decisions within your organization. As with most technical sessions, some prior experience with Microsoft technologies or similar technologies is always helpful. What are our prerequisites for this course? You may hear some various Microsoft acronyms and terminologies that I might use. I'll try to explain all the acronyms I use. It may be helpful, though, however, to be familiar prior to this session with certain technologies. First is Microsoft SQL Server. If you've had experience with our older version, SQL 7 or SQL 2000, or even the current new version, SQL 2005, at least have some type of experience with the relational database product, and I bet you most of you have that. You also should have some familiarity with database analysis, such as OLAP cubes, dimensions, fact tables, and data warehousing. Now, that's not a must, but I can have some information to help you out here if you get too lost with that. And finally, if you're familiar with the database reporting, either creating reports from online transaction processing databases or from data warehousing, that would be helpful. This is a level 200 course. It's not an entry level 100, and it's not a deep dive level 400. It's kind of in between. So we'll cover the topics at a level that most people, I think, will have a good understanding. So to keep the sessions flowing, we divide them up into the following agenda that we're going to cover today. First is we're going to do an introduction to Analysis Services and discuss many of the key benefits and features and improvements over this version of the product. After we've gone through the introduction and taken our first look at Analysis Server in action, we'll then explore how you can use Analysis Service to provide intelligent data to your organization. So with no further ado, let's dive right into it. Business Intelligence, or BI, is made up of three major components. This includes integration services, which involves acquiring data from sources or from source systems, whether those source systems be online transaction processing systems, flat file systems, or any other type of information that you want to aggregate, transform, clean up, and then perform useful analysis on it. Second part of business intelligence is analyzing that data. Analysis Services allows you to take your data in your database and enrich that data with business logic, hierarchical views, and the ability to specify parcels of information and discover data and data patterns using data mining components. And finally, the last piece of SQL Server Business Intelligence is reporting services, which concerns data presentations and distributions. How to take the data that's in your database that you've worked to integrate and analyze and make it available to your end users. The goal of reporting services is to data access for your large organization, or for any organization for that matter. Together, these components and business intelligence help you organize and make the most of your business information. So notice we've got integration services, analysis services, and reporting services, which were all part of the suite of product of Microsoft SQL Server 2005. How did we get to where we are today? Let's go through the roadmap of where we've been. Analysis services was first introduced in SQL Server version 7.0, which included online transaction processing, or OLAP services services as part of the product, and an API access to access this OLAP data for programmatic access. With SQL 7, we're then able to gain mind share by providing OLAP services as part of the product while lowering the total cost of ownership, since other database vendors provided OLAP as an expensive add-on to their database products. Then 5 years ago, when SQL Server 2000 came out, we improved our offerings in analysis services over SQL Server 7. With 2000, analysis services was feature complete, including data mining components built into the product. SQL Server 2000 analysis services was deployed in many enterprises that were new to OLAP services, and the product became a leader in the marketplace. Also, SQL Server 2000 brought many enhancements to the scalability of analysis services, enabling enterprise-wide business intelligence for large organizations. So notice we were able to scale it up. We had some limitations there in SQL 7, and we were able to solve most of those problems with 2000. What does 2005 give us? This is a breakthrough version. It's a totally new version of analysis services over previous versions. This organization allows you to build and use business intelligence applications. If you've been using SQL Server 2000, you may need to step back a little bit and explore the richness and vastness of analysis services in SQL 2005, because a lot of things have changed. And we'll take a look at those here in just a few minutes with our first set of demonstrations. So to kind of level set, let's talk about the product itself and look at what is analysis services. Analysis services is essentially a binding product that allows you to analyze data from a number of different sources. This data can come from including SQL Server, obviously, Teradata, Oracle, DB2, and other, and then create a unified dimensional model, or UDM. So I'll refer to UDM as the unified dimension model, which is like an enhanced version of an OLAP cube. There are many ways to present the business logic in terms of calculations, policy, and so on. And these are contained within the unified dimensional model. It allows you to model business logic from an analysis of the enterprise. Traditionally, analytics is performed on a cube that is rebuilt on a specific interval, which introduces data latency. What I mean by this is we then pump data out of our transactional database into a cube on some period, sometimes once a night, sometimes once a week. So there's latency. That is a delay that our cube or OLAP processing doesn't have real live current data information in it. In SQL Server 2005, the notion of proactive caching is introduced. Proactive caching, which is discussed more in detail in our different TechNet sessions on real-time business intelligence, allows you not only to perform traditional OLAP analysis and data mining, but also gives you the caching of data that's very near real-time. As a result, you can choose to have minimal data latency, or you can choose to have traditional load and run analysis, depending upon your business needs. As a result, you can gather data from many sources, have a unified model of the data encapsulating your business logic, having proactive cache that provides near real-time data that exposes the data through a unified application programming interface called the XML for analysis, or for short, XML/A. XML/A is supported by a number of vendors and allows many different kinds of services to connect to the UDM to provide data to the user. You can also use XMLA to provide data within spreadsheets and other BI front-end clients. Create ad hoc reports, data-rich reports, and dashboards. And apply it to any number of applications that can use XMLA to provide meaningful, timely business intelligence geared towards the needs of the people who need the data. We all know we have data in databases. The question is how do we get that information back out? Analysis services is one of those ways. So next, let's take a look at the features of analysis services for SQL 2005. One of the central ideas around analysis services is that your business, you want to have one version of the truth. That is, you want to have a model that encapsulates your business logic and your data and gives you a central place that you can get the right answers to your questions. To provide a single version of the truth, analysis services can pull data from multiple data sources throughout your enterprise, including, of course, SQL Server data, Teradata, Oracle data, DB2, and other database formats. You have a single business view of the data throughout your enterprise. You can build a single data warehouse and then present the single data warehouse as a series of separate data marts to departments, employees, customers, business partners, so that they have their own custom view of the single business view that analysis service provides. One of the problems with bringing together data from different sources is the terminology used within those sources can be different or completely different. Sometimes the terms can have different meanings for each data source. Analysis services allows you to create a common business terminology and definitions so that everyone who gets the information from analysis services will understand what the data really means. By giving you the ability to use a common terminology across the enterprise, analysis services helps you make better business decisions. Analysis services also let you quickly and easily navigate through the data from the front end of your choice. For example, you can browse the data through a spreadsheet, through reporting services for reports, or through custom applications. Regardless of the method that you decide to use, analysis services can allow you to have a unified view of your enterprise data. And finally, any application that supports XML for analysis can connect to analysis services. Many third-party applications such as XML that support XML for analysis, so you can use any comparable OLAP browser or the application, or even build your own custom application to get a view of the single version of the truth that analysis services provides. Let's take a look at our first demonstration. In this first demonstration, we'll take a look at the Business Intelligent Development Studio. In this environment, we'll use to define, browse, and deploy analysis cubes. We'll define data sources and data source views, define a cube, and learn about the dimensions, the fact tables, measures by browsing the cube and then deploying the cube into production. So let's dive in and take a look at the product. I'm running virtual server here, so let me reconnect to my machine here. I let it idle too long, but I'm running Windows XP as my host operating system here, and then to allow me to be able to be in our live meeting. On top of that, I'm running, as you can see now, virtual server R2, and so I'm going to connect to a virtual server that I've built for us that has on the operating system, this one is, I think, Windows Server 2003, yeah it is, Enterprise Edition, and I've installed SQL Server on this machine. As part of installing options, I selected to install, as you can see, all the different management tools here. There's a report server, I've got the Visual Studio, I've got Server Manager, and then this is the one tool that we're going to use most off today. This is the SQL Server Business Intelligence Development Studio. So as I click on that, that brings up this interface that we're going to use today, and everything is geared around projects. So all the work we do is organized into projects. So I'm going to go out here and walk you through the process of creating a new cube by creating a new analysis services project and giving the project a name. So to do that, I click up on File menu, New, and I want to create a new project. There may be times if you're listening to my voice over IP that my voice may get delayed, and so I will try to explain the steps and go very slowly through the steps as I click through the processes here. I apologize if I'm repeating everything that I'm clicking on, but I want to make sure you're able to follow along. So now that I'm creating a new project, it wants to know what type of a project I'm creating. So I'm going to create an analysis services project and give it a name. And we'll give this one the name of Demonstration number 1. and click OK. When the new project page is going to appear here in just a second, you'll see that there are several project components that you can create for your solution, depending upon what you want to do. You can define data sources, data views, define cubes, dimensions, mining structures, and defining some other components to build as well. To build an analysis cube, we first need to create a data source. If you're not familiar with it, this is the Solution Explorer. On the right-hand side, you're used to the old world of right mouse clicking everywhere and trying to figure out what to do. With the new Solution Explorer, we have a shopping list here of the things that we need to create. And we'll kind of go down the list here in order. So the first one I'm going to do is I'm going to create a new data source. And so to do that new data source, I'm going to right mouse click here and create new data source. This is going to bring up a window that allows me to point. There's a little wizard that we're going to go through. And I want to create a new connection, so I click on the New button here. And I want to actually just connect to myself. So I'm connecting to the server that I'm running on. So I'm going to type in the word localhost here. And that will connect to my own machine. And then I can come down here to the drop-down box at the bottom and pick the database that I want to work with. And so I have a data warehouse that's already been built. We're going to use the AdventureWorks DW database, which is a sample data warehouse database. It comes with SQL Server 2005. It can be used for developing OLAP and data mining examples. So you can learn how different aspects of analysis services work. So you have this on your machine whether you know it or not. This is a default database warehouse that comes on every machine. So I've connected to my own machine into the AdventureWorks data warehouse, and I clicked on OK. Once we set up the connection, we can continue to configure the data source. Notice I now have this new one here, localhost.adventureworks.dw, and I'm going to click on Next. Now it prompts me for username and password that I want to use. In this case, I'm just going to use the service account and click on Next. And it points to the data source name. We're going to leave that default, and I'm going to click on Finish. After the wizard finishes, we can confirm that the new data source has been created. The next thing we need to do after creating the data source, or the DSV, which is the new concept in SQL Server 2005. So this one, we're going to create a data source view. So I go over here to my Solution Explorer, right mouse click on Data Source Views, and click on a new data source view, or DSV. This DSV effectively gives you an offline representation of the data you can use to build your analysis services cube, as well as the integration services or reporting services connections. With a DSV, you can use to find the data and the relationships you're interested in independently of the cube itself. So again, this is going to fire off a wizard for us here. You can see I can turn those off. Okay, I'm going to use AdventureWorks DW again and click on Next here. We now have a list. There, it's taking a second to populate. There it is. So we now have a list of available objects from the database, including the fact tables and the dimensions. If you're not familiar with analysis services, a fact table is a table of data. It's numbers and representative numerical data that we can do analysis on. For example, sales information. Okay, so if I had all sales data for a bicycle company, the fact table would be the sales of which bicycle I sold and the number of items that I sold. The dimensions table, or dimensions, are information about that bicycle. So I may just have in the fact table item number and number purchased, but a dimension might be the description of that particular model number. So if you're not familiar with the data warehousing terminology, a fact table is numerical data, and dimensions may be numerical, but sometimes describes the data that we have here. So I've got lots of different objects available, too many for me to list here, so I'm going to filter this down. One of the new features here is allowing me to click on the little funnel here and type the word sales in, and it will now only show me those objects in my database that have the word sales contained in them. So I can move these objects you're interested into by clicking the right arrow. We're interested in internet sales, reseller sales, and internet sales reasons fact tables. So let's go ahead and add those three over to the right. We'll do them one at a time. So the first one I want is the fact internet sales table. I can't quite see it there, so I can resize this columns here. Oh, that didn't take first time. Bear with me. There we go. So I want the fact internet sales, and we're going to add it to the right as one of my fact tables. The fact reseller, that's the one on the bottom here. We'll add it to our list. And finally, the third one I'm interested in is the fact internet sales reason. There we go. So I now have 3 objects over here in the include objects. Now that we've chosen the objects we want to include, we're going to select all these objects and add these tables, and they're related to them. Analysis services can determine which tables from the databases are related to these tables we've already chosen and add them to the DSV. We're ready to name the data source view and finish the wizard. Okay, so what I do to highlight that is I'm going to select one of these, go up here and press the Shift key down and do a select all, and click on add the related tables to make sure it goes out there and gets any tables that may be related to those. So notice it pulled in all these other tables for me automatically. And I'm ready to click on next. And finally, we'll name it, completing the wizard, and clicking on finish. When the wizard is finished, we can see that the schema has been produced from the data source view. So take a second for this to populate. If you viewed data diagrams before, you'll notice that the DSV schema is very similar. All the related tables we just selected are displayed in the relationships at the right of the design surface. Okay, so let me resize my design surface here so you can kind of see what we're doing. There's our shopping list of the things we need to continue to finish. We'll kind of keep that over there. But I can resize this so we can navigate around things a little bit more. One of the interesting things that you see with this interface, besides just moving around things, is this lower right-hand corner here is this 4-way diagram. Watch when I drag it. If I click on that 4-way and start dragging towards the object, this gives me a little viewfinder method, okay, and allows me to search and see all of the different parts of a very complex diagram. If this is not showing currently on full screen on your machine, you can press F5, which will remove all those other windows that you have in Live Meeting. If you press F5 again, it's kind of like a toggle. It'll switch back and forth between full screen mode and showing you all the other windows that you have around on the screen. So apologize if you don't see this on the lower right-hand side here. There's a lot of things I want to show at one time. In the DSV, as we've mentioned, it's also an offline representation of the data. We can also add calculated fields. This is useful when we want to create information that isn't in the back-end database. Let's do this now with our customer dimensions table. All right, so I'm going to go find my customer table. There it is, right here on the bottom. I just happen to be in the right spot. So I'm going to highlight the gray bar, right mouse click on the banner bar, and I want to create a new calculated field. Okay, so I'm going to create, let's see if I did this right. I've got to have it selected first, then right mouse click. And bear with me, I'm not seeing the right interface I should have there, so hold on just a second. There we go, new named calculated field. All right, so this one, I'm going to create a new field, and we're going to call this one the full name. I can give it a description if I wanted to. We're going to go down to the expression here, and I'm going to type in first name, that's just one of the other fields that we've got obviously in our database, plus sign, use string concatenation, and I'm going to add a single quote and a space, another single quote between the first name and the last name. Helps if I can type that. And I think the last name field is just exactly that, last name field. We should be good to go there. Notice now I have a new field in my dimension customer table. Once this expression is created, it appears at the custom dimension table in the data source view. Note that this does not modify the back-end database at all, but simply makes a calculated value available to the cube through the data source view. This icon to the left of the names lets you know that this is a calculated field rather than a normal field coming directly from the database. From the schema of the DSV, you can also go in and directly expose data. Let's do that and see what the results of creating a calculated full name field look like. Okay, so if I right mouse click again on that dimensions table and tell it to explore the data, I'm going to go get a view of the data as it exists in that data. Take it just a second for it to go out there and pull that information for us. So we can see there's the table, customer names, graphic keys, customer alternate, first name field, middle, last name. Let's scroll all the way over to the right here. Keep going here. Let me take it a second for the screen to refresh. But there we go. Notice there's our new calculated field of full name, and it has done the exact string concatenation as we wanted and created the new field. Again, that new field is not stored in the database. All right, so let's close that. Let's go back to our schema. Now we'll explore another interesting feature of the data source view. For this example, we'll take a look at the product table. So I got to scroll up and find the product table here. I think it's on the left-hand side, about halfway up. Let's see if I can find product table. There's promotions, resellers, sales territories. There's the product table. Okay, so on that table, I'm going to right mouse click on the header of it. Again, look at the Explore data. And we can see what we've got in our product table. As we saw with the customer table, we can explore the data with a DSV. It's presented us into a table or spreadsheet format. One of the interesting things, however, is we can also see the data in other representations, such as a pivot table. So there's the table itself. Notice I can now click on Pivot Table. When I do that, the Pivot Table dialog box appears. For those of you that are Excel power users, this will be a very familiar interface to you. So let me just show you a brief demonstration of what this looks like. So in my drop-down box here, the different fields that I can pick for my pivot table. The first thing I want to select is my English product name. So select that field. And we're going to take that and drop it all the way over here on the left-hand side to the drop row fields right here. So I highlight that and let go. That'll populate that. This should show me plus or minus signs. Yep, looks like I got good plus or minus signs on each of my product names. I'm then going to take my list price, so come back over here to my selection or list of fields that I can select from, highlight it, drag it over here, and drop it out into the middle into my totals or details column. This shows us the list price for each product in the product table is displayed. Some of the products don't have list prices, which is because InventorWorks doesn't sell some of the products directly, but uses them in the manufacturing of its retail products. Both retail products and parts, however, have the same safety stock levels to indicate how many of each part should be stocked. What this shows is that just with the data source view, you can have several different ways you can look at and understand the data before you deploy it in the cube, performing any real multidimensional analysis on it. This helps you when planning and designing phase to make sure that you get the most information you wanted from your deployment. So next, from our list of fields here, we're going to pick the safety stock level. So let's find our safety stock level to make sure we have enough of that. Oops, I probably passed it here. There it is, right there, right above list price. So we're going to take that and drag it and drop it off here on the main workspace. You can also then create charts from this data from the DSV. For example, I can view the metrics of how many products you have that take a certain amount of time to manufacture. So I'm going to go to my chart tab here, now that we've got that data selected. Notice my days to manufacture response. It shows that out of the 450 products that we can manufacture within 1 day, while just a little over 100 of those products take 4 days minimum to manufacture. We'll take a look at the pivot chart as well. This chart is really dense, so we'll take a selected few products to look at, such as different sizes of the bikes they make. So once I click on this pivot chart, it's going to be kind of really hard to see there. Those are actual product names there, but too many of them for me to see. So I'm going to unselect all of those and just show you a few of them. I'm a road bike guy, so let's see if they got any road bikes here. Mountain bikes. Yeah, there we go. There's some road bikes. Notice those are different size red frames here. That's actually measured in centimeters, so we're ranging from 44 to centimeters. That's standover size, so with the top bar on a bicycle, if you're familiar with that. So there we go. That shows us several of the different sizes that they offer. Actually, I didn't pick one that didn't have any data, so no problem there. Let's say we want to see the safety stock levels for just these products. We can then drag the safety stock level field into the chart. So grab that safety stock level into the chart we just built. There's going to come my data. Aha, so I can now see of each size of bicycle of the road red frame from 42 centimeters up to 62 centimeters. Most of them have about a 1,400 or 1,500 minimum stock that we want to keep on those bike frames. Again, there's the point here is that you have some powerful tools at the data source view to examine, model, and understand your data even before you go and finish creating your data cube. So let's go ahead and close that interface and stretch back out my solution, what I call my shopping list. So far we've built data sources. We've built the data source views, which is a new feature in SQL Server 2005. And so next is to build our data cube. So right mouse click on cubes, and we're going to build a new cube. It's going to walk us through the wizard. We're talking about UDM, or Unified Dimensions Model. You can think of it as a cube. However, since the UDM can encapsulate your business logic and other rules in addition to just the data, the UDM cube is much more powerful than any sort of traditional OLAP cube. There's a couple of different ways you can build a cube. You can build a cube top-down by choosing to build the cube without using a data source. So here, if I go through the example, I don't necessarily have to have a data source. I could go through and manually build it from a template. And notice some of the templates that are out there automatically. Whoops. And I lost connection to my server there. Bear with me just a second. It thinks we weren't doing anything, so we'll go back to it just a second. Sometimes that happens. I'm using an external hard drive, and there we go. But this time I do want to build one with data connection. When creating a cube without a data source, you can use templates, which are predefined models that we can provide you with for the basis of your own cube model. You can also use those templates, as I was referring to customize to have the dimensions, measures, and other schema properties as you need. You can also build your own cube templates by designing a cube and then saving the cube definition to a file templates folder, which can then be used as a template for creating future cubes. For this demonstration, however, we're going to use the data source that we've already defined and auto-build the features and let you automatically create hierarchies and attributes, or just attributes. We'll let analysis services create both the attributes and the hierarchies for our cube. Okay, so this one we're going to build one, auto-build it. Notice I could create the attributes only if I only wanted to do that, but I'm going to have it auto-build the attributes and hierarchies for me. So I click on the Next button, which should bring up the data sources view. We'll use the data sources view we defined earlier. An analysis service then detects the facts, tables, and the dimensions in the DSV that we've chosen. Okay, so the one that we selected and been working with, we select it by default. For example, how many outgoing relationships is most likely the type of a fact table. So notice it gives us and reviews that information, so I can click on Next. And now it brings up me all the dimensions tables that I have. Once Analysis Services performs a sort of analysis on your schema, you can then see what is detected from the fact tables and the dimensions, and alter the suggestions if needed. In our example, in each table is listed either the fact table or dimensions table. Note that the tables, such as the time dimension table, can either serve as both fact tables or dimensions. Oh, excuse me, the reseller table is what we're going to use both either as a fact table or as a dimension. For this example, do we not want to use the reseller table to be used as a fact table, but only as a dimensions table? Okay, so let's go ahead and change the setting on that. There's my reseller table, and we're going to clear the checkbox and having that as a fact table. So the dimensions of reseller table is only a dimensions table now, not a fact table. Now we can select from the columns from the timetable map and specify time properties. So I can specify my own time periods for our own time dimension. Okay, so let's look at time. And click on Next. And allows me to be able to create the time dimensions that I want. And it should have prompted me for time here. Let me make sure I selected that correctly. Got this one. Let's see if we can get that correctly now. Oh, I know what I did. Here we go. Time dimension table. I need to pick time. There we go. I was picking the wrong dialog box. Bear with me. Now let's do next. Aha. All right, that looks better. So in any cube that we're dealing with, we have to have a dimension of time. And we have to know how we divide up time. So here we're going to specify that if we don't have a field that has that for us automatically. So we're going to say yearly. What's our function for year? We're going to use a calendar year. What's our half year? We'll select calendar semester. There we go. Hope I'm not going too fast here. And calendar quarter, I'm going to select as my quarterly function. There. Okay. So now I have a time dimension specified, so I can click on Next. Next, we can select which measures and measure groups we want to use in the cube. Measures and measure groups are a new concept that are similar to facts and fact tables. A measure contains a fact, and a measure group contains multiple facts. For example, the fact internet sales measure group contains several measures that map to the facts within the fact tables. One important distinction between measure groups and fact tables is that the fact table can be a member of many different measure groups, even though in this example there's a one-to-one relationship between the facts and measures. You can define more complex relationships between your facts and measures depending upon the needs of your cube. Okay, notice lots of different available measures that are out there. So we're going to click on Next there. Analysis Services now determines and examines the relationships between the dimensions in the table and the data source view and detects the hierarchies. This will take us a few seconds for it to run. There we go. Looks like it created everything that we needed, and we can click on Next. And let's expand our time dimension to see if our time settings got set the way we want. Notice it develops it both into hierarchies and into its attributes. Analysis Services is automatically create a hierarchy within the time dimension. The hierarchy goes from year to semester to quarter, which is appropriate for our purposes. Another new feature of SQL Server 2005's Analysis Services is that you can use the attributes of the dimension to create a new hierarchy within the dimension table. In 2000, if you wanted to create a new hierarchy, you had to go and create a separate dimensions table. Now, however, you can rearrange the attributes as needed to create separate hierarchies within the same dimensions table. So here, if I've expanded hierarchies, all right, everything looks good there, so we click on the Next. Now we'll name this cube. Okay, so I want to call this the Adventure Works Data Warehouse. Oh, we'll just call it Demonstration. There we go. And click on Finish, and that should go build our cube for us. The wizard creates the cube structure we define and then shows us the result. The schema looks similar to the schema of the DSV we were just created earlier. So this should look very familiar to the DSV. Dimensions tables have blue header. Fact tables have a yellow header. Based on this example, it's clear that it's more complex and robust than the star or snowflake schema used in traditional OLAP cubes. In fact, you can have a fact and dimensions table with many-to-many relationships, which is a new feature of SQL Server 2005. We can also have multiple fact tables. In this cube, you're using two different fact tables, the internet sales and reseller sales, to give a comprehensive picture of the sales throughout our organization. In SQL Server 2000, to do this, we would have had to have different separate cubes and then defined a virtual cube to bring the separate cubes together. Now with the UDM or Unified Dimensions model, you can bring all of your data, relationships, and business logic together into one single cube. So there's my design space that I've got for this cube we just built. Notice over here in my Solution Explorer, all my next step is my dimensions, and it's populated all these dimensions for us automatically. Let's look at some of these attributes in more detail. And under my dimensions here on the lower left-hand corner, let's look at, if I can resize this so you can see everything that I'm doing here. There we go. And I want to look at time, because time is the thing that we really needed to work with and make sure that we had all our dimensions set up correctly. And where did our time go there? Let's see, that's under the attributes. Nope, under our hierarchies. And we should have had a hierarchical there for time, and it doesn't look like it got built correctly. There we go. So there's under my ship date, I've got a time. And I think we also have one under order date. So I'll just show you one example one here. The one I'm looking for isn't set up correctly. But based upon our time dimension and all the different fact tables, so I've got the breakdown here between quarter, semester, and year. I can edit these if I want to. So let's go back to, instead of the order date, let's go back to due date. So let me go back here one screen and close that one. And let's pick due date instead of order date. There we go. Let's pick this one. And we're going to edit that time dimension. There we go. Now we're where we're supposed to be. So I've edited the time. Due date's a representative of dimension time. We can actually go in and edit this item directly from the due date hierarchy. Once again, we can see the year, semester, quarter attributes. If we want to modify the existing hierarchy, we can drag another column from the time table and drop it into our hierarchy. So here I've got my timetable. And let's say, for example, if I pick the day, number of month field, this one right here, and just drag it over here and drop it, I can then change this dimension to have a different hierarchical structure. The day, number of month field that we just added to this hierarchy is automatically added to the attribute of the dimension time dimension. As mentioned earlier, we can also define completely new hierarchies. For example, we can define a new hierarchy using the date, number of the month, and the week, number of year from the dimension table. Again, adding these attributes to the new hierarchy also adds to the dimension time dimension. Each attribute can participate in different hierarchies and be exposed as different hierarchies within the same cube. This is a fundamental change from previous versions, allowing you for flexibility of your dimensions and your hierarchies. However, though, it's important to be careful when you include these attributes in your dimensions and designing hierarchies. You may be tempted to include all the attributes and create many different hierarchies within the intention of using them at some point in the future. The more attributes you add to your dimension, the more you'll add to the join that will create the cells for your cube. Doing this can have significant performance impact on your cube because you can end up creating an enormous cell spaces in your cube that you have to traverse in order to find data. It also adds to the amount of time it takes to process your cube. So let me just show you that real quickly. For example, if I wanted to create a new day of the month feature, okay, so instead of day of the year, I could do, let's do, what should we do here? Day number of the month I could actually add as its own attribute. So if I highlight that and drag it over here into this white space, and then as part of that, I want to do the week of the year. So there we go, week number of the year, and drag it to that level. Okay, notice it creates new hierarchies for each one of these. Again, allowing you lots of different flexibility capabilities of that. But again, it may not be what you want to do depending upon the processing time that that's going to take. All right, so let's go ahead and close that project. Yeah, I'll go ahead and save those items out. And that concludes our first demonstration. So what did we look at in that demo? We looked at how to define a data source, a little bit of introduction to data warehousing and data systems analysis. We created one of the new features in SQL Server 2005, a data source view, and then we explored the data by building our first cube. There are a number of reasons why you should use analysis services to provide business intelligence to your organization. We've talked already, let me advance the slide there, there we go. We've talked already about how to build the structure of the model of the one version of the truth. A core ability of analysis services is providing data enrichment and analysis to the environment. The SQL Server 2005 Analysis Server, the Unified Dimension Model, or UDM, allows you to have business logic rules and calculations to be embedded within the model itself. You can use business logic to stored within the model within any business intelligence application such as Excel. Analysis Services also provides the key performance indicators, or KPIs, which are strategic metrics that allow you to define and keep track of information important to your organization, such as the number of sales, call volume, and so on. You can also do data mining and predictive analysis, including real-time analysis using the predictive cache. SQL Server has different data mining models that you can use directly with the BI Development Studio We'll take a look at some of these data mining models in just a few seconds. Using the data and business logic stored in your model, you can then perform what-if modeling to help see different scenarios in the future that may affect your business, which helps you make intelligent business decisions. Let's go right back to a demonstration and see how this works. In this demonstration, we'll take a look at how the translate cube metadata into other languages, browse cube metadata into another language, and use perspectives to provide a window into your model. Then we'll look at how key performance indicators provide strategic metrics. So back to my virtual environment. So again, I'm running virtual server here, and I'm got back to my Visual Studio 2005. So here I'm going to go ahead and open up a previously saved one that I've built. And I've got an analysis services database that we've already created, and I want to open up a project solution that we've already built. So I've got to navigate here to, this is a sample one that should automatically be on your machine. So I'm going to look into Program Files. You should have this if you have SQL Server 2005. And so under Program Files, SQL Server, version 9, so 90, Tools, this is kind of a long path here, Samples, so this is the sample data, AdventureWorks, and I'm going to select the Enterprise one. There's both a standard and enterprise version. There we go. And within Enterprise, I'm going to select this AdventureWorks.sln. Okay, this is a project that's already out there. You have this on your machine, so click on Open, and it'll bring it up. It'll bring up the schema for this cube. It's much more complex than the cube we designed in our first demonstration. There's several fact tables, many dimensions, and multiple complex relationships in the cube. So as soon as our cube editor comes up here, it will show us the relationship between all these. There we go. Give you an idea of what all we've got here. Let me move this over a little bit. And this one a little bit so you can kind of see what all we've got going on here. This is a big cube, a big design platform. And if I click on the little foray away again here, you can see all the different fact tables, dimension tables, and the relationships that we have that make up this sample database that this system comes with. One of the new things that we've introduced with SQL Server 2005 is the ability to provide localized metadata. If your organization has offices in different countries or even works with multiple languages, it can be important to provide multilingual solutions within your organization. With SQL Server 2005, you have the ability to provide transitions for the cube metadata for whatever language you happen to use. For example, Spanish and French translations of the cube metadata are available. So if I go to the Transitions tab here, and so notice here I've got translations. I can do the Spanish tab a little bit smaller so I can see all the French translations. So it will change from the default English language to Spanish and to French. When a client connects to the cube or identifies itself as a French or Spanish language client, the cube will automatically provide metadata in the requested language. So let's take a look at the internet sales amount row. And also I have in my dimensions, I've got data, actions, name sales, calculated members, all the information that I need. So let's go back to our cube structures. Click on my cube button here. And we'll look at the product dimensions. The product dimensions have many more hierarchies than our first demonstration. Again, reminding you that one of the features of SQL Server 2005 is that dimensions can have many hierarchies, and each attribute in a dimension can participate in many different hierarchies. If you're looking at the Transition tab for the dimension, you'll notice that each attribute in the dimension has a Spanish and French translation. You can add translations to any languages supported by the operating system. Okay. So let's take a look at product. And click on my edit product information here. And notice now I can click on the Transition tab, and it will translate for me automatically. If I want to pick a particular one, if I look under the Attributes, and let's pick Category. There's Category. And there is what it changes it to in Spanish. And if I click on the little ellipse here, it will show me all the different ways that I can do the translation. You can also specify the particular sort order and collation designator for this item as well. You can browse the cube to see how localized metadata works. To do this, we'll need to take a look at the Internet Sales Measure. Okay. So let's go ahead and click Cancel here. And I want to look at the Browser tab. This may take it a couple of minutes for this to come up. And it's usually not quite this slow, so hopefully it'll come up here in just a second. There we go. Notice I can change my language here. And before I do that, let's see if it'll bring up any of the products here. There we go. Okay, so I can see things defined out for me. And if I change that into a different language, let's go to, oh, I don't know, we were working with French before. And let's use the French version of French, or France version of French. Notice how it makes the changes very quickly for me. And I could change that right back to English if I wanted. That's my default language that I've got specified for this database. As you can see, it brings it straight back. It looks like about all the time we're going to have here for this second demonstration. So let me go back, and I want to make sure we leave time for questions and answers. And if I have a little bit of time at the very end, I'll come back and show you the KPI portion of this. So let's go up and finish these slides first. Analysis Services has been designed to improve response time to end-user queries so that returning data from your cube or your BI application is much faster than in previous versions of SQL Server. Caching data from OLTP database as well as pre-calculated data means that Analysis Services can return data to yours and your application rather quickly. This UBM, or Unified Dimensions model, also helps protect the backend sources, such as the OLTP databases, from exhaustive user queries. Large queries that can run against your OLTP databases can lock tables and rows as well as tie up valuable CPU resources, slowing down or even preventing transactions from occurring in a timely fashion. By connecting BI application front ends to the Analysis Services cubes, thus the backend databases are isolated and can be devoted resources to providing the best response to moment-to-moment transactions required in your business. Analysis Services cubes can have traditional multi-dimensional OLAP or MOLAP cubes, or you can use proactive cache or help provide near real-time access through your cubes. You can also use relational OLAP or ROLAP to access the source's data directly if needed. The SQL Server 2005 product line has been designed to be more reliable and highly available than ever before. Analysis Services is an integral part to SQL Server 2005 and has grown into a stable platform providing business intelligence. In keeping with this idea, Analysis Services now supports up to an 8-node failover clustering capability to help ensure that your business intelligence system is available at all times. If one node were to go down, your system continues to operate. Analysis Services was designed for round-the-clock, 24/7 operations. Manageability has been improved by integrating Analysis Services into SQL Server Management Studio. Analysis Services also supports SQL Server Profiler for monitoring and capturing events. With this feature, you can use Profiler to monitor query performance and to see which multidimensional or MDX expression queries are hampering your performance of your system. As with other aspects of SQL Server 2005, Analysis Services has been designed to secure by default. You can fine-tune your access to your analysis cubes and the data within your data warehouse to help keep data safe and keep your database servers running smoothly. Improvements have been made to over access to add and manipulate the data of Analysis Services. Analysis Services made several improvements in scalability. You can now manage large amounts of data, create complex data models, and perform complex calculations on data, all within the model itself. As we've discussed throughout this session, you can use XML or for analysis to connect to Analysis Services. As of right now, there are a great many applications and vendors supporting XMLA, such as other Microsoft applications such as SQL Server Reporting Services, Excel, SPSS for statistical analysis, and Hyperion System for Business Intelligence and Analysis. As you can see, we have a lot of vendors and partners on the right-hand side here that are already supporting this new technology. UDM provides a rich, easy-to-understand model of your data and your business logic. The model is easy to use for end users, developers, and IT professionals to understand, work with, and extract meaningful information from your database. Important point is that we mentioned today is that there's a great deal of support for SQL Server 2005 Analysis Services and UDM because we expose the data through XML for analysis and open standards supported by hundreds of applications from a variety of vendors. UDM has a powerful calculation engine that allows you to present information to applications and users that is calculated within the cube. For example, you can create a calculation that will create a field with a full name from first and last name or aggregate to call volume or sales volume information without those calculations having to be performed by your OLTP database. As we mentioned earlier today, the UDM can also use data directly from sources such as SQL Server, Oracle, and DB2. Your users can have and applications can go through a single place to get useful information from a variety of sources spread across your enterprise. UDM was designed for high performance and end-user queries, even over a large volume of data. UDM can cache both data reads from the sources of the database and pre-calculate values based upon the source data. Performance of these queries is improved by encapsulating your business logic, rules, and calculations within the model. So users who need business intelligence to make timely decisions don't have to wait till they get the information they need from Analysis Services. SQL Server 2005 is a robust, high-performance OLTP database server. There are several scenarios which make sense to get the business information directly from an OLTP database. For example, if you need to exploit database-level objects such as views, user-defined types, or store procedures, you'll need to access the underlying relational database directly instead of going through Analysis Services. If you want to use end-user queries that query the data outside the UDP, you'll also need to use the SQL Server OLTP database to allow this type of query. While Analysis Services can provide proactive caching to enable near real-time reporting of information, if you need up to the second exact real-time information, it's best again to use the information directly from the database. And also full text searching included with SQL Server 2005 can only be used in a relational database. So if you need to use that in your query, you'll need to query the database directly. So let's see what we've covered today in this quick 1-hour session. SQL Server 2005 Analysis Server is a watershed product release. What we mean by it, it's all new from the ground up. It's completely redesigned. So even if you're familiar with Analysis Services from 2000 or with other database analysis server from another vendor, you'll benefit by spending some time learning and getting down the learning curve exploring this new release of Analysis Services. From multilingual support and new data sources to greater scalability and manageability for SQL Server Management Studio, there have been a great number of advances of Analysis Services since our previous release 5 years ago. The Unified Dimension Model, or UDM, as we've mentioned many times, is a new breakthrough technology in the heart of SQL Server Business Intelligence architecture. Beyond what you can do with traditional OLAP cubes, you can now incorporate business logic directly into the model to provide one version of the truth throughout your enterprise. To get more information on what we've covered today, you might go to Microsoft.com/TechNet. You can also visit Microsoft.com/TechNet/SQL-08. That is this session to give you more information on books, courses, and certification and other community activities around analysis services. So now it's time to submit your questions. If you have anything, click on the button on the lower right-hand side, and I'm going to go and see what kind of questions we've got out there in the queue and turn it back over to Tracy.
Excellent. Thank you, John. Remember, for more information, everyone can print a PDF of today's session. To do that, just go to the File menu in your upper navigation bar. And like John said, we will be getting to the questions and answers here shortly, so go ahead and feel free to submit your questions now. Also, I'm going to be posting a survey here in just a minute. If you could please take a moment to fill it out before you log off. We do appreciate your feedback. And for upcoming and previously recorded webcasts, you can go to microsoft.com/webcast. You can go here to access this webcast, which will be available for download in about 24 hours. Also, if you have any webcast content ideas, if there's something out there you'd like to see and haven't yet, we'd love to hear from you. I just want to take note of this URL here. And for anybody who's interested in getting a free 14-day trial of Microsoft Office Live Meeting, you want to go to microsoft.com/presentlive. And here's the survey for our session today. Please follow the links provided to complete today's webcast evaluation. And John, looks like we do have a question waiting there for you.
Yeah, it looks like just one question from Bill, and Bill's question has to do with what versions of SQL Server does analysis services come with, and specifically he was asking about SQL Anywhere. I hate to tell you, but SQL Analysis Service does not come with SQL Anywhere. The way you're going to get analysis services is going to get either the Enterprise Edition or I think even the Standard Edition. Now that depends upon licensing that you get. So make sure if you're going to a retail location to buy SQL Server, very few people do it that way, but if you're going to do that, flip it over and look at there's a list of the differences between Standard and Enterprise Edition, and that'll tell you what you're looking for is analysis services. But the SQL Anywhere, the low-end product, does not include this analysis services capability. Sorry to disappoint you, Bill, there, but it's not included in that version of it. So if you got any other questions, again, we'll hang around here for a few minutes and answer those. But if you don't get a chance to submit the questions here, you can always email me. Again, my email is john.weston@microsoft.com, or go out there and check my blog. All kinds of good technical information out there all the time. So I'll sit here and wait for some more questions and turn it back over to you, Tracy.
Excellent. Thanks, John. We'll go ahead and answer those to the text manager when they do come through. And with that, I do want to extend a special thank you to John for presenting today, and I'd also like to thank the audience for attending today's TechNet webcast. Well, ladies and gentlemen, this does conclude today's session. The audience may now disconnect from the audio portion of this presentation.